Good day, studybuds. This is your studybud Glenn, and join us in today's adventure to the study world. Here's the summary of what we'll learn today. Today, we will be talking about the origins of math. Mathematics is everywhere, and it is the best way to make sense of the world. So it is just as important to know its origins and breakthroughs as it is to learn how to use it. The origin of mathematics traces back to counting, and its definition is self-explanatory. We count every day, from our balon, ang cambio sa aton, score sa volleyball, kag kung pila ang itlog sa ref. But when did this begin? Mathematics around the world. First stop, Congo. The oldest record of counting today is the Ishango bone discovered in 1950 in the Democratic Republic of Congo. It is approximately 20,000 years old. The 10-centimeter long bone contains notches that many scientists suggest were used for counting. The oldest known tablet with mathematical computation also came from Mesopotamia around 2700 BCE. There, H is the multiplication table in cuneiform, possibly ginagamit sa mga students before. And around 1,000 years later, the circular tablet YBC 7289 was created in Babylon. Here, makita ang geometric diagram sang isa ka square, kag iya diagonals, and makita man diri ang computation sang length sang diagonal in cuneiform. And since na-solve nila ang diagonals, that means the Babylonians knew the Pythagorean theorem more than 1,000 years before matao si Pythagoras himself. Isn't that amazing? Na-estimate dason nila ang value ng square root of 2 up to 6 decimal places, and imagine that it was just 1,700 BCE. Then around 1,000 years later, Thales of Miletus theorized that if 2 points are the endpoints of the diameter of a circle, any other point on that circle connected to the endpoints will make a right angle. And he is the first person to have a theorem named after him. Then years later, the renowned Pythagoras proved one of the most important theorems of all time, which is named after him. The Pythagorean theorem has helped scientists and mathematicians years later in dealing with problems involving distances. Just a side note, Pythagoras was so obsessed with numbers that he founded a school where students worship numbers and mathematics as if they were a religion. Eccentric, right? Around 200 years later, the famous philosopher Aristotle pioneered the study of logic, a field of mathematics that deals with reasoning and arguments. This field of math has helped mathematicians through time to prove hundreds of theorems. Now let's try to hop to the list. Mathematics around the world. Around 2,300 years ago, the 21 bamboo strip was created in China to serve as a multiplication table in base 10. Diba? Mathematics grew everywhere. contemporary with the bamboo multiplication was the renowned geometer Euclid. With his 5 postulates in his book The Elements, Euclid single-handedly laid the foundations of your entire high school geometry with his 5 postulates. Imagine that. Anyway, Euclid was also the first person to conjecture that there's an infinitely many number of primes. After then, prime numbers has been a topic of interest of many aspiring mathematicians. Eratosthenes, around 1 century after Euclid, made a rather tedious yet efficient method of calculating prime numbers. It's called the sieve of Eratosthenes. He also was the first person to solve for a close estimate of the Earth's circumference just by using a rod. Brilliant! Years later, gindevelop naman ni Apollonius of Perga ang ginatawag natin sa bunga conic sections, which was further developed later by the marker educator Hypatia. In around 500 CE, Aryabhata was working in trigonometric functions in the golden age of Indian mathematics. Trigonometry is the study of the parts, sides, and angles of a triangle. Without trigonometry, the mathematics in engineering and physics will be pretty nasty. Around 200 years later, the oldest known account of the use of 0 was inscribed in a stone from the Khmer civilization in Cambodia. Ang iba niyang mga civilizations before, wala gityas ang 0 in their numerical system. So the Khmer 0 was then passed down to the Indian Hindu-Arabic numerical system. In 780 CE, the Persian mathematician Muhammad al-Khwarizmi was born. He has been called the father of algebra, and you know why it's called algebra? The word came from the title of the book of al-Khwarizmi, and he's a favorite. The word algorithm is also named after him. Then around 300 years later, Diophantus made an impact in the history of mathematics with his Diophantine equations, where the integer solutions are sought, and they are still an object of research up to the present. Speaking of algebra, algebra is often described as the unifying fabric of mathematics. It connects all of mathematics into a system. It is the study of mathematical symbols and the rules governing them. Anyway, are you familiar with this sequence? This is the Fibonacci sequence by Leonardo Pisano, aka Fibonacci, born in 1175 CE. This sequence has fascinated humans through time since it is the most usual pattern of nature. From shells to sunflowers, even to the number of petals of a flower, you can see Fibonacci. With the Fibonacci sequence everywhere, mathematics is indeed real and almost tangible. But mathematics has not been free from scrutiny. In 1545, Girolamo Cardano, in his book Ars Magna, tried to solve the equation x times the quantity 10 minus x equals 40. Solving this, we know that the answer would be imaginary. But more than a century ago, accepting the concept of imaginary numbers is only for the eccentric and could tantamount to heresy. Even Cardano said that problems with imaginary numbers are a mental torture. So you're not alone, study buds. Then years later, the mathematician René Descartes showed his dislike of these numbers and called them imaginary as a form of derogation. However, Raphael Bombelli in the years that follow showed his unconditional love for imaginary numbers by introducing the symbol I. Though it didn't make much impact in the mathematical community during his time, he paved way for the development of a new field of mathematics called complex analysis. This field started as a branch of pure mathematics that studies complex numbers and its properties under different operations of mathematics. But guess what? From pure mathematics, this field transcended to applied mathematics after discovering that it is essential to solving physical problems. Complex analysis is used in aerodynamics, fluid dynamics, electric power generation, and mathematical physics. From being called as imaginary to advancing. What a glow up. Oh, we've gone a lot with imaginary numbers, right? Let's go back to the real ones. We mentioned René Descartes, and he's most famous for his use of the real XY coordinate system, which was named the Cartesian plane after him. The idea of the coordinate plane system started when René Descartes in his living room found a fly at his ceiling. He then wondered how would he know the exact location of the fly. Then he realized that by finding the distance of the fly from one edge of the ceiling and its distance from the adjacent edge, he could find the exact location of the fly. Voila! The coordinate system. He then developed analytic geometry, which is the geometry of the XY plane. But a lot of geometry was yet to discover, including projective geometry, differential geometry, orthographic geometry, descriptive geometry, algebraic geometry, and many more. Are you overwhelmed with geometry? Let's jump to another interesting part of mathematics, number theory. Number theory deals with the properties and relationships of the most basic component of mathematics, numbers. One remarkable person of number theory is Pierre de Fermat. In 1637, he wrote a short note in the margin of his text saying that a raised to n plus b raised to n equals c raised to n has no integer solutions for n greater than 2. And you know what? He claimed that he had a marvelous proof which this margin is too narrow to contain. This equation became known as the Fermat's last theorem, and its proof remained unsolved for more than 300 years later, until it was proven just recently in 1994 by Sir Andrew Wiles. If only Fermat shared to us his proof, the world would be at peace ever since. Just a few years after him, another field of mathematics was born, calculus. Isaac Newton and Gottfried Wilhelm Leibniz invented calculus separately. Some symbols used in calculus are also attributed to them, such as the f prime to Newton and the d over dx to Leibniz. But what is calculus? A quick and dirty definition is that calculus is all about limits, infinities, rates of change, and accumulation. Calculus has immeasurable applications from finding various rates of change, areas and volumes of irregular figures, to modeling the spread of disease. Calculus is extremely helpful. It's used in physics, economics, medicine, epidemiology, navigation, and many more. It helped a lot of scientists, including Albert Einstein, in formulating his famous E equals mc squared, and Erwin Schrödinger in describing the atom. Cool, right? But math doesn't end there. In the same century as Newton and Leibniz, Abraham Demoivre put up a bridge that relates trigonometry and complex numbers. It's now known today as the Demoivre's formula. And aside from that, he also played a major role in statistics and probability by discovering the formula for the normal curve and conjecturing the central limit theorem, which is essential to the field. But what are these subjects? Statistics is the process of collecting, organizing, presenting, analyzing, and interpreting data sets. Probability, on the other hand, as the name suggests, the study of mathematical certainties. These two, when used efficiently, can help us describe and have an insight on a certain phenomenon and even predict the future. Do you know a much better duo than statistics and probability? Levity aside, let me introduce you to another famous legend in the history of mathematics. The ancient city of Königsberg in Germany was divided by the river Pregel, separating the city into 4 separate lands connected by 7 bridges. The mayor of Königsberg one day wondered if there is a way such that you cross all the 7 bridges just once and still return to your original location. He tried his best to solve it, but he could not find one. He's so frustrated to that point that he consulted the renowned mathematician Leonhard Euler, who's also known for the beautiful Euler's formula, if he could find any mathematical implication within the problem. At first, Euler scoffed at him, saying that there's nothing mathematical about it. But after studying the problem carefully, Euler found the answer. The answer is no answer. That means you cannot cross all the 7 bridges once and still return to your original location. And this problem led to the foundation of another field of mathematics, which is called the graph theory. This subject studies networks and interactions and has been pretty useful in scheduling flights, finding the shortest distance for mailman, and even finding the structure of molecules in biochemistry. Fun, isn't it? Then, with the death of Euler, the crown of mathematics was passed down to the Prince of Mathematics, Carl Friedrich Gauss. Gauss was a genius after making remarkable feats in the field, including his proof of the fundamental theorem of algebra, which states that every polynomial of degree n has n number of solutions. He also helped in laying the foundation of non-Euclidean geometry, where the fifth postulate of Euclid doesn't hold true. That means, in non-Euclidean geometry, parallel lines could meet. Interesting, isn't it? There's still a chance for the lovelorn parallel lines. Gauss is not called the Prince of Mathematics for nothing. And we have reached the 1800s. One remarkable mathematician during that time was Bertrand Riemann. Is the name familiar? He was the one who made the Riemann hypothesis, a complex analysis problem which up to the present remains unsolved, and is one of the 9 Millennium Prize problems. When this problem is solved, it will give mathematicians a good lens for viewing the distribution of prime numbers. He was also famous for giving the first rigorous definition of an integral in calculus. On top of that, he pioneered in the study of differential geometry, which gave Einstein a scaffolding for his theory of general relativity. Another remarkable mathematician during that time, just a few years before Riemann was Augustin Louis Cauchy, the ground founder of complex analysis. Just fun fact, of all the mathematicians out there, Cauchy has the most number of theorems named after him. Such a smart guy. Anyway, have you heard from someone that some infinities are bigger than the others? Well, for mathematics, that's George Cantor, who pioneered in set theory. Set theory, as the name suggests, studies about sets of numbers. He also found an efficient way of writing all the rational numbers. Contemporary with Cantor was Henri Poincaré. He was one of the founders of topology, a branch of mathematics that studies properties of spaces that do not change under any continuous deformation. In topology, cups and donuts are the same! He also gave a partial solution to the three-body problem that caused a headache to Newton more than a century ago. He maintained that the motion of three celestial bodies in space can be unpredictable, and this paved the way for the development of another field of mathematics called chaos theory, the mathematical study of chaotic systems, especially those which are very sensitive to initial conditions. And are you familiar with the butterfly effect? That one minute action can cause a cataclysmic consequence? It's actually inspired by this field of math. Math has been very progressive even from the very beginning up to the present. In the 20th century, many mathematical achievements were reached. David Hilbert formalized the foundations of mathematics. The notes of Srinivasa Ramanujan, the man who knew infinity, has gained the interest of mathematicians across the globe. Kurt Gödel proposed the existential crisis of math with his incompleteness theorem, saying that mathematics contains unsolvable problems. Benoit Mandelbrot discovered the Mandelbrot set, which people call as the fingerprint of God. He then developed the field of fractal geometry, which studies fractal or self-repeating patterns. John Nash put mathematics to a higher pedestal by applying it to economics and by developing the field of game theory, the mathematics of games. Then, a revolutionary feat for mathematics when Karen Uhlenbeck developed modern geometric analysis and won the Abel Prize, one of the highest awards in mathematics analogous to the Nobel Prize. Then, just in 2003, the Millennium Prize problem proposed by the topology guy Henri Poincaré, remember him, was solved by the Russian mathematician Grigory Perelman. Take note that solving one of the Millennium Prize problems comes with $1 million as prize, but Grigory Perelman rejected that and said, "I'm not interested in money or fame. I don't want to be on display like an animal in a zoo." There are so many colorful people behind mathematics, with their geniuses and passion to streamline the field of mathematics. The world has been in a smooth technological advancement, and they too deserve to be recognized. Just what I said at the very beginning of this video, math is the best way to make sense of the world, and knowing its history and breakthroughs is as important as knowing how it works. And this has been your Study Bud Glenn. Till our next trip to Study World, Study Buds.